Alright, today's lesson is going to be to solve radical equations. Our first step is going to be to isolate the radical, or the exponent. And then we're going to square both sides, or we're going to raise both sides to the reciprocal power. We're going to solve for x, and then we have to check our solutions, because there's going to be times where we have extraneous or solutions that don't work. Alright, so look at part B where it says type 1. Type 1 is when we have a variable under the radical. We're going to solve this problem and check. So step 1 is always to isolate the radical. So if we look right now, we need to get this radical by itself. So in order to do that, I'm going to subtract 3 from both sides of the equation and get root x is equal to 5. Well, we have to get rid of the radical. So if we look at step 2, it says square both sides. And that should make sense, because if I have a square root, to get rid of a square root, I want to square that, because the square root squared is just going to give me x. But I can't just square the left side, I have to square the right side. So 5 squared would give me 25. So 25 is my solution, and I do need to check this. So before I go ahead and box this, I'm going to say 3 plus the square root of 25, is that equal to 8? Well, 3 plus root 25 is 5. 8 does equal 8, so that check works, and I know that my solution is a solution to the equation. It's not an extraneous root. Let's look at number 2. Again, I want to isolate my radical, so let's start by subtracting 2 from both sides of the equation. 6 minus 2 is 4. This is a square root again, so to get rid of a square root, we square both sides. When I square a square root, I just get whatever is inside. 4 squared is 16. And now I'm going to continue to solve, so I'm going to add 2, which will give me 3x equals 18. So I divide by 3, and I'm going to get x is 6. All right, before I go to circle that answer, let's do a quick check. So my check is going to be, let's see, 2 plus, I'm going to plug in x as 6 and say, does that equal 6? So 2 plus, I have 18 minus 2 is 16, square root of 16 is 4, so that gives me 6 equals 6. So indeed, x equals 6 is a solution to our equation. All right. Now number 3, I have to start by isolating my radical, all right? But what I mean by that is it's 2 times the radical. So let's start off by dividing both sides by 2. So I have the cube root of x plus 3. 8 divided by 2 would give me 4. Now, I can't square both sides, right? I'm taking the cube root here. So if I'm taking the cube root of something, to get rid of that, I'm going to cube both sides, because the cube root cubed would make that disappear. So I would get x plus 3 is equal to 4 to the 3rd power is 64. And then if I subtract 3 from both sides, I'm going to get 61. All right. So before I circle that, I do need to go back and check. I'm going to say 2 times the cube root of 61 plus 3, is that equal to 8? Well, 61 plus 3 is 64. Cube root of 64 is what times what times what gives me 64, and that's going to be 4. So is 2 times 4 8? And it is. So I indeed know that 61 is a solution. All right, let's try number 4. Again, always start by isolating the radical. So I need to isolate this radical by subtracting 6 over to the right side of the equation. It's the square root of 5x plus 1 equals negative 6. So if I square both sides, the radical drops out on the left side. Negative 6 squared is 36. If I subtract 1, I'm going to get 35. And if I divide by 5, I get 7. So everything looks totally fine. Let's go ahead and check that. If I go ahead and check, and I put square root of 5 times 7 plus 1, and I'm going to add 6 to that, does that equal 0? Well, 35 plus 1 is 36. The square root of 36 is 6. Well, that's a problem. 12 does not equal 0. This is not going to be a solution. I'm going to reject this. Since I only had one solution and it didn't work, the answer to the problem is no solution. And I want you to go back and look. See if I can get some more pen colors. If you go ahead and look at the very beginning of the problem, all right, when I isolated this radical, I have a square root equal to a negative number. you can be able to tell from now on, hey, if I have a square root equal to a negative number, that is never going to work. I can never get the square root of something to be negative, so you could know that your answer is no solution. The good news is if you don't see that and you solve, if you do check your solutions, you'll reject your answer and you'll know that there is no solution to that problem. Okay? All right, let's try the next section. So now type 2, now we're going to give you the equations with rational exponents. All right, our first step is still going to be the same, meaning I'm going to isolate this term right here, like the x to the rational exponent. In order to do that, I'm going to have to divide by 2 first to get rid of that 2 out front. So let's divide both sides by 2. So I'm going to get x plus 3 to the 3/2 power is equal to 27. Now, this problem is a little bit different than the first 4 because I'm not just to a root. I was a cube root or a square root. Now I'm to a power and a root. The way to get rid of that is I'm going to raise both sides to the reciprocal power. So I'm going to go back up to my notes here. It says square both sides or raise both sides to the reciprocal power. Reciprocal means I'm going to flip over whatever the fraction is. So instead of 3/2, what I'm going to do is I'm going to raise both sides to the 2/3 power. Put green in here. So let's raise this to the 2/3 and raise this to the 2/3. The reason why I'm going to do that is because now my 2/3 and 3/2 will cancel. I'm left with x plus 3. And then 27 to the 2/3 power is similar to what you did in 7/4, where I'm saying, okay, let's take this is my power, 2 is my power, and 3 is my root. What is the cube root of 27? Well, the cube root of 27 is 3. What's 3 squared? That's going to give me 9. Right? If you need to do this work more on the side, where I'm saying, oh, let's do the cube root of this guy and square it, you obviously can do that, okay? But the 27 to the 2/3 power is going to be 9. If I continue to solve for x, I'm going to subtract 3, so I'm going to get x equals 6. I do need to check the solution. You're going to go back to the very beginning of the problem, and you're going to check your solution. So I'm going to say 2 times 6 plus 3, so that'd be 9 to the 3/2 is equal to 54, and I'm checking if this is actually correct. Now, you have to know again how to deal with rational exponents. If I have 9 to the 3/2 power, I'm saying what's the square root of 9 and then raise it to the 3rd. So the square root of 9 is 3. 3 to the 3rd power is 27. Is 2 times 27 54? And it is, so I know that solution will work my equation, and I'm good. All right, let's look at number 2. Again, to start off, the biggest mistake we're going to make is if we don't isolate first. So make sure we have to isolate this first. Since it's 2 times that stuff, let's divide by 2 to begin the problem. So I have x minus 2 to the 2/3 power is equal to 25. All right? Because I'm raised to a rational exponent, to get rid of that rational exponent, what I want to do is raise it to the reciprocal power. So instead of the 2/3 power, if I raise it, I'm not multiplying. I'm not multiplying by 3/2. I'm raising the left side to the 3/2 power. I'm going to raise the right side to the 3/2 power. The left side will cancel. I'm left with 25 to the 3/2 power. Again, what this really means is what is the square root of 25 to the 3rd power? Well, the square root of 25 is 5. 5 to the 3rd power is 125. And then if I add 2 over, I'm going to get 127. So my final answer is 127. Do a check back in your original problem. So if I do 127 minus 2, that's 125. I'm trying to find out if my left side is equal to 50. Well, the cube root of 125 is 5. 5 squared is 25. Is 2 times 25 equal 50? And it is. Right, so make sure you check all your solutions because you are going to have extraneous solutions for some of these problems. All right, type 3 is where there's an x on the outside of the radical. All right, we're going to solve and check these. All right, if there's an x on the outside of the radical, I still want to start by isolating my radical. So I want to isolate this radical. So I'm going to say square root of x minus 3 is equal to, I'm going to subtract the 5 over. All right. Since the square root, just like kind of in part, I think it was part B, if I have a square root, I'm going to square both sides to get rid of that radical. Now, the trick is here. I have x minus 5. If I square that, you have got to FOIL this. The most common error is for you guys to say, oh, that's x squared like plus 25, and that's not true. I have to actually think about what x minus 5 times x minus 5 is, and that's FOILing those binomials out to get my solution. So if I FOILed, I would get x squared minus 5x, so that's minus 10x, and then negative 5 times negative 5 is positive 25. When I get down to this step, we're going to be looking to factor, right? Because I have an x squared, an x, and a number. Let's get everything on one side. So I'm going to subtract the x, and I'm going to add the 3 at the same time. So I'm going to get x squared minus 11x plus 28 is equal to 0. And what I'm going to need to do is I'm going to need to factor this and get my solutions and then check my solutions. So if I FOIL this out, I'm going to get, let's see, what multiplies to give me 28 adds to give me negative 11. It should be 7 and 4. So when I solve those, I get a positive 7 and a positive 4. All right. So I need to go back and check those. Let me just erase this here so I have some room. Let's go ahead and check 7 and check 4. If I can, let's see. So let's plug in 7. Oops. Come on, pen. There we go. Let's check 7 in green. So we're going to say square root of 7 minus 3 is 4. Is that plus 5 equal to 7? Well, 2 plus 5 is equal to 7. So I know right now that x equals 7 is a solution. Let's try 4. Square root of 4 minus 3 is 1. Is that plus 5 equal to 4? Well, 1 plus 5, that is not going to be equal to 4, so I'm actually going to reject the 4. So this is not a solution. X is 4 is not. The only solution that works is x equals 7. All right, let's look at number 2. Again, the first step is to always isolate. So I need to get that by itself by subtracting 3 to both sides. I have 5x minus 1 to the 1/2 power is equal to x minus 3. Well, 1/2 power, if I raise that to the reciprocal power, the reciprocal is going to be 2 over 1, which is really just going to be squared. So meaning if I take this and raise it to the 2, or square it, the squared and the 1/2 will go away, but I've got to be careful again. I have to FOIL x minus 3, meaning I need to do x minus 3 times x minus 3. So if I FOIL that out, I would get x squared minus 6x plus 9. Just like the first problem, I'm going to have to factor this guy. So I've got to get the 5x over and the negative 1 over. Meaning if I take away 5x from 6x, that's going to be 11x. If I add 1 to the 9, I'm going to get 10. If I factor this guy, I'm saying what multiplies to give me 10 and adds to give me negative 11. I know it's 10 and 1, but it's got to be minus 10 minus 1. So that would be x equals 10 and x equals 1. All right, we're going to have to check this again. So on this side, I'm going to say to myself, let's plug in each of these problems and say, okay, if I check, well, let's say we do 10 first. 5 times 10 is 50. 50 minus 1 is 49. So I have 49 to the 1/2 power plus 3. Is that equal to 10? Well, the 1/2 power is really the square root. So 49 square root of 49 is 7. 7 plus 3 is 10. So that one does indeed work. All right, let's try 1. 5 minus 1 is 4. 4 to the 1/2 power is really 2. Does 2 plus 3 really equal 1? That is not going to work, so I'm going to reject the 1, and the only solution to that equation would be x is 10. All right, let's move on to the last part, type 4, where there's radicals on both sides of the equation. These can either be very simple or they can be a little more lengthy in doing algebra. So let me do number 1. It looks super tricky, but if we ever have radicals on both sides, what I actually want you to do is split up the radicals, meaning let's keep the 3x plus 2 on the left, and let's add over the 2x plus 7 to the other side. And this is going to be the easy example, and you'll see why. If I have a radical on the left and I add it over the radical on the right, to get rid of a radical, since it's a square root, I could just square both sides. Well, before we had this happen, the square root and the squared would cancel out on just one side. But if you look at this example, since this is a square root, I'm squaring it, it's going to happen to both sides. And now I just have a simple algebra 1 equation. Let's go ahead and solve for x. So x plus 2 equals 7. I'm going to take away 2. I'm going to x is 5. You do need to check it, right? So go back in the beginning and say, okay, if I plug in 5, 3 times 5 is 15. 15 plus 2 is 17. So I have root 17. Minus 2 times 5 is 10. 10 plus 7 is 17. Does that equal 0? And it does. So x is 5 truly is a solution to the problem. All right, let's do the next one. Again, I want to start similarly where I'm going to move this guy over to the other side. So I'm going to leave one radical on the left, and then I'm going to leave 4 minus x minus 4 on the other side. Okay, if I go to square both sides, this is where it gets tricky. All right, I square the left and square the right. Squaring the left, piece of cake. Square root of a square is just going to be x plus 4. However, these are really two terms, meaning I have this is a term and this is a term. This is a binomial. If I have a binomial squared, I'm going to have to FOIL that. So I'm going to write this twice, and we're going to FOIL through just like we've done before. It's a little trickier because we have radicals, but you just do the same process. So I'm going to leave the left side alone. I'm going to say 4 times 4 is 16. 4 times a negative root x minus 4 is negative 4 root x minus 4. If I do the inners, so that would also be a negative 4 times square root of x minus 4. Now when I go to do my last, negative negative is positive, and when I'm doing root x minus 4 times another root x minus 4, the nice thing about that is I'm just going to get x minus 4, right? When I have a radical times itself, whatever's inside comes out. So let's simplify. X plus 4 is equal to, let's see, 16 here and minus 4 here. That looks like it's going to give me 12. So 12, I have a negative 4 times root x minus 4, another negative 4, so negative 8. All right, so I'm down a couple steps. I've done a lot of work. And if you realize, I'm kind of now going into kind of an equation from part B, where I have one radical and I want to isolate this radical. So let's start isolating the radical. I'm going to move 12 over, so x minus 8 equals negative 8 times root x minus 4. Again, I still want to isolate that radical. So in order to do that, I'm going to divide both sides by negative 8. Oops, hold on, did I miss something? 4. One sec, why am I looking up like I'm missing something? Plus, oh yeah, I forgot my x here. So this x here, it's looking like something was wrong. I'm going to erase this a minute. So go back up to this step where I'm going to, I put these together, and I put those together, but I forgot about my little x here. If I have my x, before I divide, if I minus the x, which makes this problem a little bit easier, my x's will go away. So I have negative 8 is equal to negative 8 times x minus 4. Now I'm going to divide by negative 8. So I'm going to get 1. Let me scroll down a little bit. I'm going to get 1 is equal to x minus 4. And now we're back to the very beginning where I have a radical isolated. I'm going to, since it's a square root, I'm going to square both sides. X minus 4, the root of that squared is just x minus 4. So if I add over 4, my final answer will be 5. Okay. If you go to the very beginning and plug in 5, it looks like I'm going to have what? Square root of 9, which is 3, plus square root of 1, which is 1. Does 3 plus 1 equal 4? It does, so that's going to check out. All right. I'm going to go ahead and do another example just like that on number 3. If you feel confident that you know how to do number 2, you can go ahead and stop the video, or you can try to do it on your own. But we are going to do problems like 2 and 3 and expect you to know how to do those. So I'm going to do another example, which is going to follow the same process as the one we just did. So if I have 2 radicals, I want to get 1 radical on the left. I'm going to subtract over the root 3 minus x. Once I have isolated radicals on each side, I'm going to square both sides, which will make the left side nice to x plus 10. But the right side is a binomial, so I'm going to write this twice, and then I'm going to have to FOIL that. So x plus 10 is equal to 5 times 5 is 25. I'm going to have minus 5 of those and another minus 5 of those. So minus 5 and minus 5 would be minus 10. And then negative, negative is positive. 3 minus x is what's underneath my radical, so that's what's going to come out. I'm going to simplify, leave the left side. Let's simplify the right side. So 25 and 3 is 28. I still have that minus x, and then I have the negative 10 times root 3 minus x. Let's subtract the 28 over, and let's add the x over at the same time. So moving these to the other side of the equation, I would get 2x minus 18 is equal to negative 10 times root 3 minus x. All right, let's go ahead and divide all of those. Let's see, by, let's start out dividing everything. Actually, I'm trying to think what would be the easiest for you guys. Let's divide everything by 2. Meaning if I take this whole equation and divide it by 2, left side and right side, that would give me x minus 9 is equal to negative 5, 3 minus x. And you don't have to do that, but if it's going to make my math a little simpler, I'm going to go ahead and do that. Now I'm going to divide by negative 5. Yeah, let's do it this way. Sorry, we can do it another way, but let's do it this way. Divide by negative 5. Now I'm just going to leave that, so I have x minus 9 over negative 5 is equal to the square root of 3 minus x. Since I have a square root, I'm going to square both sides. Now when I square the right side, I'm just going to get 3 minus x. When I square the right side, you got to be careful. This is a binomial, so you're going to have to square that, meaning x minus 9, you're going to FOIL that. So my numerator, when I square this, would be x squared minus 18x plus 81. And then my denominator is going to be negative 5 squared, would just be 25. All right. I'm going to have to get everything on the same side. So what I'm going to do is I'm going to multiply both sides by 25. I'm come work over here. That would leave me with x squared minus 18x plus 81 is equal to 3 times 25 is 75, and then minus 25x. And now I have a square term, an x term, and a constant. I need to go ahead and get everything on one side. I need to move over the constant and move over the variable. That would leave me with x squared. If I add 25x to 18x, I get 7x. If I add if I subtract 75 from 81, I'm going to get 6. And if I add the 25x to the 18, I get 7. So that's what I'm going to get when I combine. If I factor this, it's going to be x plus 6, x plus 1. I'm going to get x equals negative 6, x equals negative 1. And both of those do check out. You're going to want to check those, but I know we're kind of over time. Go ahead and check those two solutions. Each of those would work. Okay, so they get very tricky sometimes when you have two radicals on each side of the equation. Sometimes they're very easy, like problem number 1, where you just move over 1 and square it. But when there's multiple terms, you're going to have to square that with a radical.